Lesson 8.G.6 starts standards about the Pythagorean theorem. So this first standard, 8.G.6, is about a proof of the Pythagorean theorem. And so we're going to start here with problem number 1. It says select all statements that are true about right triangles. It says the angles in a right triangle are always 30, 60, and 90 degrees. And that is not true. It can be, but one of the angles has to be 90 degrees, but the other two can vary. Then given a right triangle, if you pick any two side lengths, their sum equals the length of the third side. Well, that would be something like picking 3 plus 4, and that would have to equal 5. I do know that 3, 4, and 5 make up a right triangle, and this is not true, so this one doesn't work. The next choice, if a triangle has sides of lengths A, B, and C, so if it has A, B, and C, then, and it has A squared plus B squared equals C squared is true, then it must be a right triangle. That is a true statement. The next statement says, in a right triangle, the sum of the two non-right angles equals 90 degrees. Well, we do know this. We know that there is a 90-degree angle plus some angle plus some other angle, and that adds up to 180 degrees. So if I take away that 90-degree angle, then I just have that the two remaining angles add up to 90 degrees. Well, that is a true statement. And then the last one, all right triangles are similar triangles. This is not true because that would mean that they would have to have the same angles. They're not always the same angles, so they can't all be similar. Number 2, which set of side lengths forms a right triangle? Well, we test these by plugging them into a squared plus b squared equals c squared. So I'm going to take this first problem and we're going to plug it in. Remember, which side has to always be C is the longest side. So I'm going to plug in 11 for C, and then 2 and 5 could be A or B. We'll call it 2 and then 5. So 2 squared plus 5 squared, we'll see if it equals 11 squared. Well, 2 squared is 4 plus 5 squared is 25, so we get 29. 11 squared is 121, so is 29 equal to 121? No. So this is not a right triangle. Let's test out this next choice, B. Our longest side would have to be C, which in this case would have to be 10. And we'll plug in a squared plus b squared equals c squared. So C has to be 10. And we can plug in 6 and 8 in either order. I usually say the smallest to largest, but as long as the largest side is C, it doesn't matter about your other two sides. And 6 squared is 36 plus 8 squared is 64, which comes out when added to equal 100. And 10 squared is also 100, so this is true. So yes, that is a right triangle. If you tested the other choices out, they would both come out to be no. Oops. Number 6, triangle DEF has side lengths of 5 centimeters, 13 centimeters, and 12 centimeters. Use the converse of the Pythagorean theorem to prove that DEF is a right triangle, and then write numbers 1 through 4 to order the steps. Well, we're going to prove it's a right triangle, so we always start with the formula, and that is your first step. And then we plug in the side lengths. The longest side is 13, so it has to be C. And then we've got 5 and 12, and they can be A and B in either order. And so that is our second choice. Now, if we're going through and showing all our steps, then we would show that 5 squared is 25, and 12 squared is 144, and 13 squared is 169. So that is our third step. And then our final step, we add 25 plus 144, and it comes out to 169. And that is true, and that was our fourth and final step. And so therefore, it is a right triangle. Standard 8.G.7, and these are problems that just use the Pythagorean theorem. We're going to start with this problem number 1. What's the length of the hypotenuse of the right triangle? So I always start with my Pythagorean theorem, the formula a squared plus b squared equals c squared. And looking at this right triangle, the hypotenuse is this longest side. We know it's across from this 90-degree angle, and it's labeled C. And then the other two sides that are shorter are called the legs. They meet at the 90-degree angle, and we could call them A or B. So I'm going to call 8A, and I'll call 15B. But I could have swapped the order of those. And so we simplify. 8 squared plus 15 squared comes out to 289. And then to get C by itself, we take the square root of both sides to undo the square with C. And we get that C is 17. So the hypotenuse is 17 centimeters. Number 2, find the missing side length to the nearest tenth of a centimeter. So I start with the formula a squared plus b squared equals c squared. And this time we have got that the hypotenuse is 8. So we'll plug that in for c. And we don't know what one of the missing sides are, one of the legs. So I think I'll call that missing side A, and I'll call 6B. And we simplify. 6 squared is 36. 8 squared is 64. Subtract 36 from both sides. And so now we get a squared equal 28. And then to get a by itself, we will take the square root of both sides. And a is about 5.3. So we get 5.3 centimeters. A wizard walks into a wand shop to purchase a magic wand. He chooses a wand that is 22 centimeters long. Will the wand fit into the box shown? Explain. Okay, so this problem is going to deal with finding a three-dimensional diagonal, a diagonal within a three-dimensional figure. And so we're trying to figure out if a wand will fit in the box. And so you take the longest measure you can find within the box. And in this case, that would be along this dotted line. Notice it goes from the back top right corner to the front bottom left corner. And so to get to that, I'm going to need to figure out this dimensions along this figure here. So I want to find this length first. Okay, so I'm going to make this right triangle along the base of the figure. So we're going to call this the flat diagonal. It's the one that's on the bottom of the figure. And I'm just naming it that. I see one side's 21, and one side would be 6, since the other side matches it as 6. And those do form a 90-degree angle because it's within a rectangular prism. And so we'll plug into a squared plus b squared equals c squared. We'll plug in 6 and 21, and we'll solve for c. Well, 6 squared plus 21 squared is 477. And so when we take the square root of both sides, we get that c is about the square root of 477. We could get a decimal value there, but it's not going to be exact, and we're going to need this value again, so we're just going to leave it alone and use that square root of 477 in the calculations. Now, let's get our three-dimensional diagonal, the one that's in three-dimensional space. That'd be the longest length within this box. And we're going to use a squared plus b squared equals c squared. And we know that we have the square root of 477 plus this height would be 5 units tall. And what we don't know is the three-dimensional diagonal that we're looking for. So that's our unknown. So we're just plugging in what we know and solving for c, what we don't know. Square root of 477 squared is 477, plus 5 squared is 25. We add those to get 502. And then when we take the square root of both sides, we can go ahead and round at this point to get that c is about 22.4. And since the wand is 22 centimeters long, yes, it will fit. Yes, since the box can fit 22.4 centimeters. So it can obviously fit less than that. Okay, standard 8G8. These problems involve distance, and one way we can find distance is using the Pythagorean theorem. We're going to start with this problem number 1. Find the distance between point A and point B. Round your answer to the nearest unit. So I'm going to find this distance between point A and B. I need to create a third point that has the same x-coordinate as one of those points and the same y-coordinate as the other point, which this point would work. It will have the same x-coordinate as point B and the same y-coordinate as point A. And another way we can look at that is that it is below point B and to the right of point A. And so it forms a right triangle because we have a vertical distance and a horizontal distance. So let's pick out what we know. From A to this new point is 4 units wide, we just count. From B to this new point is 6 units tall, we just count. And what we're looking for is C. So we're going to go to the Pythagorean theorem and plug in what we know. 4 squared plus 6 squared equal c squared. 4 squared is 16 plus 6 squared is 36, and that comes out to 52 equals c squared. And then we're going to take the square root of both sides, and we get that c is about 7.2, and we're rounding to the nearest unit, so we get 7 units. Number 10, what's the perimeter of the trapezoid? Round your answer to the nearest tenth. Well, when we go to find the perimeter of a figure, we just add all the sides. So the top of this I can count because it's just a horizontal distance is 3 units. The bottom of this trapezoid I can count because it's a horizontal distance, it's 6 units. But I can't count these other two diagonal side lengths. So I'm going to start over here. And I'm going to create a right triangle using this extra point that just turns it into a right triangle so that we have a vertical distance, 3, and a horizontal distance, 2. So we can calculate C, which is that diagonal distance. And so we plug in 2 squared plus 3 squared and calculate C. And 2 squared is 4, plus 3 squared is 9, and that adds up to 13. And then we just take the square root of both sides. And C is about 3.61. Since I'm going to round to the tenths place, I'm going to go out an extra place here and do the hundredths place, just so that I have an extra decimal place for when I calculate the adding in a little while to be sure it's as precise as we can be. Okay, so we've now found that that is 3.61. Now we want to calculate this measure. So we make a right triangle here, It's 1 unit wide and 3 units tall. And we'll plug in to a squared plus b squared equals c squared. So we've got 1 squared plus 3 squared equals c squared. 1 squared is 1 plus 3 squared is 9, so we add them to get 10. Square root both sides to get c by itself, and c is about 3.16. Once again, we went to the hundredths place. And I'm going to write that in here, 3.16. And so the point of that was so that we could get the perimeter. It's where we add all the sides. So we're going to add 3 plus 3.16 plus 6 plus 3.61 just by going around the trapezoid. And that adds up to 15.77. But remember, we're rounding to the tenths place, so 15.8 units.